Good morning. We're going to look at some different types of logarithmic equations to solve. The previous log equations, remember, we used the properties to combine two logs into one. Okay, and then we canceled the logs on both sides. Well, in this case, notice there's a log on one side but not on the other side. So in order to solve this, we need to change forms. So in order to change forms, we're going to change from logarithmic to exponential. So in order to do that, we start by writing down the base first, raise it to the exponent, set it equal to the argument, and then we solve for x. Okay, so when you only have one logarithm, you can go ahead and change it to exponential form and then solve it. Okay, number 2, let's go ahead and set this one up. So we start by writing down our base. Okay, we raise that to our exponent. And we set it equal to the argument. And now we solve for x. So to solve this for x, we have x to the 3/2. So let me use a colored pencil here. No colored pencil, but a pen will do. So to cancel out our 3/2 exponent, we're going to raise that to 2/3. And if you raise one side to 2/3, you have to do the same thing to the other side. Okay, so remember the rule, exponent to exponent means to multiply. So 3/2 times 2/3 is 1. Okay, now we have 27 to the 2/3 power. 27 caret 2/3 power, and the answer is 9. X equals 9. Okay, let's take a look at number 3. We write down the base first, raise it to the exponent, and set it equal to the argument. Alright, so what do we have here? X to the 0 power is equal to 2. Well, remember the rule, anything raised to the 0 power is 1. So we end up with 1 equals 2. Well, that's not a true statement. That's a false statement. So the answer is no solution. Remember, if your variable disappears, you have two choices. Either it comes out to be an infinite number of solutions or no solution. If it's a false statement, it's no solution. If it's a true statement, for example, if this was a 1, 1 equals 1, then it would be an infinite number of solutions. Okay, on to number 4. Let's see, we have 2 as our base, raised to the x power equals 64. Okay, so this one's a little bit different. Now, in order to solve this type of equation, what you want to do, if you can, is make the two bases the same. Okay, so if I was to make this base 2, might need to do a little calculator help here. 2 to the, let's say, 3rd power, 8. We want 64. 2 to the 5th power. Not quite. 2 to the 6th power. Okay, so 2 to the 6th power is equivalent to 64. So I'm going to rewrite this as 2 to the x equals 2 to the 6th power. Okay, so at this point, we can cancel out the 2's by taking log base 2 of both sides. Because remember, exponents and logarithms are inverses, so logarithms would cancel out exponents. Okay, so we're going to have log base 2 on both sides, which will cancel out the 2. So I'm just going to go ahead and do log base 2, and on this side do log base 2. Now I'm going to use the power property and move my exponent down front. Move my exponent down front. Let's rewrite this. So we're going to have x log base 2 of 2 equals, bringing that exponent down front, 6 log base 2 of 2. Okay, and so these cancel, and we end up with x equals 6. Now, it's pretty obvious right here when you have 2 to the x equals 2 to the 6 that x equals 6. In order for them to be the same, x would have to be a 6. But I wanted you to see the math as to how we came up with that answer. Okay, let's look at number 5. Remember, if you have any questions or you're confused, please see me in class. I'd be glad to help you. Okay, number 5. Here we go. Do you have your seatbelts on? Good. Starting off by writing down our base. Raise it to the 4th power. Set it equal to the, what's that called again? That's right, the argument. This time the argument is a group, so we have to set it equal to the whole group. I do not need to put it in parentheses because it's by itself. Okay? Alright, now we're solving. So 2 to the 4th power. 2 times 2 is 4, times 2 is 8, times 2 is 16. Solving for x. Solving for x. Whoops! Early morning mistake. Sorry about that. 25. Okay. So let's see. If I plug 25 back in, 25 minus 9 is 16. 2 to the 4th power is 16. So, excellent job. Excellent job. By the way, for you faithful followers and watchers of my videos, thank you. Thank you for watching. All right, page 2. We're at 9 minutes. 6 to go. Got 3 problems left. We'll see how this goes. I might add another one here. All right, so this case, we cannot change it to exponential form until we take care of these numbers in the front here. We need to get rid of them, okay? So get this log by itself so we can change it to exponential form. So we're going to start off by subtracting the 15. That's going to cancel out the 15. Okay, then we're going to get rid of the 2 by dividing by 2. Okay? Now we can change it to what? Exponential form. That's right. Good job. So we're going to start by writing down the base. Raise it to the exponent. Set it equal to the arguments. All right. So we just need to know what 2 to the 5th power is. And I believe that would be 32. This is fun. I love doing logarithms. All right. Whoa, what do we got here? This is a little bit different. A little bit different indeed. How do we handle this one? So let's think about this for a minute. How would we handle this one? You know, the thing about math is it's not boring. Each problem is different. And you have to use your brain. It's like a puzzle. It's so interesting. You have to be creative. You have to think. You have to struggle. You have to ask questions. And it's so fulfilling. Because once you find that answer and you understand, you feel so smart. And you feel like you can do anything you set your mind to. So please keep working at this math. You can do it. Okay? You can do it. All right, I got an idea. Let's take this logarithm over here and let's move it over here. That'll give me 2 logarithms that I can combine into one using one of our properties. And I think I'll take this -2 and move it over here, because once I get that one logarithm and I have a number on the other side, I can change it to exponential form. You're like, wow, Mr. Kramer, how did you see that? Well, it comes with experience. Okay, as you practice, you gain experience, and as you gain experience, you can apply that to future problems. Okay, so let's do that. So to move this to the other side, we're going to go ahead and add it. Since it's minus, we're going to add it. So log base 8 of x, add that on both sides. And let's go ahead and take care of this at the same time. Move that over here to the other side. Okay, so that cancels on this side, that cancels on that side, and now we have less talking, more working, Mr. Kramer. Come on, got to get through this. You have that. Notice my bases are the same, very important. Okay, picking up the pace here just a little bit using the product property of logarithms. We are going to multiply our arguments here. Yeah. Now we can go ahead and change it to exponential form. Okay, 8 squared is 64. Whoopsie. Wonder why 64 and 16 always seem to get exchanged. All right, 64 equals 4x. Dividing by 4, x equals 4 goes 1 time, 24, 6 times, 16, 16, yeah, 16. All right, number 8. And hey, don't be afraid to ask me if you don't understand something, okay? Don't keep it to yourself. Ask your partner, ask me, ask somebody. All right, here we go. Number 8. Ooh, what do we do here? We got to think about our properties. Okay? We got to think about our properties. And you know, there's not always just one way to solve a problem. You can sometimes attack problems different ways. Okay? So I'm just going to talk this out. I'm going to let you try to figure this one out. I'm going to talk it out real quick. Notice the 2 logs on opposite sides. Okay? It's very similar to the one above, except an additional step is needed. Another property needs to be used, and it has something to do with the number in front. Okay? So I will be checking number 8. Please do it. Find the answer. You can do it. All right. See you guys when I see ya. Later.